Hello. So in this video, we are going to talk about traffic management, right? So basically, let's just take a simple example. We have a query service, which is currently basically when we give a order ID, um, it will actually give us order detailed information, right? With ship to shipment ID, booking ID, and all other information about the order. Now, what we wanted to do, we wanted to release a new feature in this particular API, where we also wanted to give how much time this particular query took to execute. And we just wanted to provide this as part of the response body. So without even touching to Istio, we wanted to just use Kubernetes and see how Kubernetes is going to solve. Basically, we wanted to have a 50% traffic going into the new service or new version of the service, and the other 50% going into the existing service. So other 50% should not be displaying new information about the execution time, but the new version should, right? So how are we actually going to do that? So if we go back to our um, deployment file, we have we already have a deployment for the existing version of the service, which we tagged it as a latest, and the version is currently tagged to 2.3. What we can do, we can actually create another deployment where we can make the replica 1, and we tag this as a upcoming version, and also the docker file tagged as a 2.6 upcoming. Now this particular docker file should have the functionality of showing the extra information about the execution time. So what will happen here is that um, it's basically we just were deploying two different workload connecting to the same service, having a different version. One is actually having latest and another one is having upcoming. And when we deploy this, Kubernetes service will basically transfer or divert traffic based on the round robin. So 50% of the traffic will go to the one service version, and the other one will go to the new service version. So let's do that. So let's just quickly deploy first. Um, so for deploying, we're gonna just apply, and this will basically reconfigure our new version, which is basically upcoming. And if we see our uh, resources, we should be able to see two pods for query service running. One is upcoming and one is latest, and both having running currently. So let's just go and test that. Now, what should happen here is if we actually test using Postman, let me just get the auth token first. Now, what should happen is one request should actually get the new information and the other request should not. And that should be like 50%, right? So this one doesn't have, the other one should have, which is basically the execution time, right? And this execution time, nothing but how much that controller method in Spring Boot took to execute. And if I just submit again, it should not have. So it's kind of 50-50, right? But so that's fine. That's works with just a normal Kubernetes configuration. But if we want more sophistication, is basically we want only 10% traffic should go here, and other 90% should actually still be showing the existing service without the execution time. In that case, we need Istio, because that is where Istio provides custom definitions, custom resources, which will allow us to configure more different logics around the traffic management. And that is one of the kind of a key feature of Istio traffic management, is basically where we can define the weight to how we wanted to transfer a request between services. That is where we can say weight 10 versus 90 or whatever. So the 10% should actually go to the service, one service, and the other 90 will go to another service. So let's just configure that and we can then test it. So in this case, what we need to do is, that is where we need to now introduce a kind of a terminology called virtual service. which is basically a custom resource provided by Istio. This is nothing to do with the Kubernetes, but this is basically kind of an abstraction from or abstraction provided by the Istio to configure some more sophisticated logic around traffic management. So what this virtual service is actually doing. First of all, of course, it's a kind virtual service, which is a custom resource. But what it's actually doing is providing a mechanism where we can configure multiple different instances of our application, and then provide a weight, how much percentage of traffic we wanted to forward or direct to those service, right? So if you see here, we are if you just if you just literally read, you will be able to understand that the latest is nothing but a version tag which we provided when we deployed our query service. So one deployment was tagged with latest and the other deployment was tagged with upcoming, and that actually refers to the logistic query service. And what we are doing is we are actually using those versions and defining the weight around those versions. So latest, we are saying latest should be 90% and upcoming should be 10%. So around that, like 6 or 7, 8 requests should actually go show without the execution time, and 1 or 2 requests around that should actually show execution time. It's not exactly 90 versus 10, but it's around that area. So let's just quickly deploy this file first. Virtual service weighted. Okay, so both destination rule and the virtual service has been created. And what we can do is we can just quickly go and test that in our Postman. So right now, what will happen? Let's just get the new auth token just in case. Okay, so basically what we can do is it's quite hard to actually test here, but what we can do, we can just um, get the um, curl code and then we can just run through our terminal. So here is the new field should actually come here. So this is currently is actually taking from the old version. It's still taking, yeah, so now it is coming here after 3 4 execution. So it's not exactly the same, but it's kind of varies. And normally when you actually run for a long time, it will automatically adjust and then it will give you more accurate. um, Now it is coming, so yeah, it's give you more accurate, percentage. We can also kind of see, if you go to Kiali, we can also see how this graph is working. So if I just go to the service, actually workload, and the one thing I wanted to show you that is actually showing a new icon which basically talks about there is kind of a routing logic or a traffic management applied, and you can see that is actually going to one workload and another upcoming workload. And what we can do is we can just show a response, a request percentage, which is kind of all right because it's actually showing 86% going to the new the latest one, and then 13 point some percent is actually going to the upcoming one, which is kind of roughly 10% and 90% what we just configured. So this is how it's actually works. Now the second use case where we wanted to actually have more accurate kind of a traffic management, but based on a certain data which user provides, right? So that will be quite accurate. So for example, if you are releasing a new feature and we new feature of the API, and we actually notify some user to use certain information to get the new feature, in that case we can make sure that the request will always go to the new feature whenever that particular information is applicable. So what that information could be, like, it's probably we can probably use HTTP header. So we can introduce a new header, and whenever user who is consuming our API provide that header, will always gonna get the new feature. In that case, we don't need to really guess how much percentage we need to divert, and that will be a quite a accurate and quite less risky approach to test a new feature directly in production. So to do that, let's just create a virtual service again, reconfigure virtual service basically. What it will do is it will actually check the header, which is basically saying X release header, and it will actually expect a a value called canary. And once you provide that value, that particular request should always land on upcoming, which is our new version tag, and rest of the request will always go to the latest. So we can test that very quickly, and to do that, let's just apply that configuration first. So it is basically header, it yeah, so it's showing is reconfigured. And if we go to our postman, let's just quickly get the auth token. And now what we need to do is basically we need to provide this particular header. Let's just do this first without providing the header. So in that case, we should actually get the original response. So let's just take the auth token first. And yeah, so we should not be getting, sorry, we should not be getting a new information or the execution time. And it looks like we are always going to the kind of old or the latest version, not the upcoming version. And we can actually also check here. So in last 1 minute, it should show 100% is actually going on to logistics service rather than going to the service upcoming. Okay, so now what we can do is we can just add a header, which is basically X release header, and the value will be canary. If we send this now, it should actually give us execution time information as well. And every time we actually sending this request, we always going to get duration or the execution time, and that would basically will have traffic going. Now if you see, of course it's just last 1 minute, but if you wait few more seconds, it should actually increase to 100% from 93%. So that's working, that's really good. Now the next thing we wanted to actually do, it's basically we wanted to, whenever the request coming to our production service, we also wanted to kind of parallelly send this same request to other service where we can collect and do some other kind of testing. So it's basically mirroring a production production flow or a production data request into some other service where we can actually analyze and we can actually test and get feedback around it. And that is also something which we can actually achieve using Istio. Istio provides kind of a configuration in virtual service. So if you see in this virtual service, what will happen here is that we will land onto the latest always, right? So without the execution information basically. And what will happen is that we are also forwarding the same production request to our new service as well. So without even user knows, all the data, all the request um, goes to the new service as well, where we can internally test and analyze whether this feature can be released to the production or not. So let's just quickly apply that as well and see how it's actually looks like. Of course, in Kali, you will not be able to see any traffic going into the new service, but in the new service, you should be able to see that the new service is talking to the database almost 100% to actually fetch that information. So let's just apply this first. Okay, so this is configured. Now what will happen here is the the header should not really matter because we have reconfigured the virtual service and remove header. So we should not be getting the execution time. So let's just take the auth token first and then just submit this few times. So of course, header doesn't really matter. We can even remove header and it's always going to be without execution time. Now the how are we going to actually make sure? Of course, we are not getting any execution time. So that's one thing. But other thing is when we actually go here, um, and if we, yeah, so if we actually check here, um, let me just minimize this little bit. Yeah, so of course 100% traffic going to the new the latest service which we reconfigured, so that is good. You won't see any traffic going to the upcoming service, which is also good, but you can see that the auth the the upcoming service is actually making a call to the auth service for token validation, which is basically proving that the 100% call are actually mirroring to the upcoming service as well, because there is an internal communication happening at the same time when we actually doing call to the query service. So that's kind of a mirroring feature we are talking about. The last thing in this particular scenario I wanted to actually go through, when we wanted to, for some reason, we identified there is a problem in our existing production service, and we wanted to kind of suspend some traffic based on certain logic, so that the consumer or the user of that service will get certain errors which we can actually propagate. In that case, the scenario will be to actually, sometime what happened is, because of some kind of a resource contention or something, that particular service is actually bringing down or slowing all other services as well if there are dependency. So in that case, we will basically configure certain user defined custom errors, which will automatically propagate those errors and stop processing anything in that particular faulty service. So we can actually kind of release traffic on other services as well. And this is called kind of fault injection in Istio term. So what we can actually do here is that we can define what error we wanted to actually throw. So this will hit the service, but it will not execute the payload, and straight away a proxy where we actually configuring or our virtual services will send the request based on the error which we configured here. And what we are saying here is that, okay, whenever we hit this particular service, right? What will happen is, if sorry whenever we actually identify a particular header, which is basically um, X release header and the value is canary, we will generate a HTTP error code 503, and the percentage of generating this error will be 50%. So we wanted to just release some traffic but not totally bringing that service down. Now there are other patterns or other logic also we can add, apart from X release, apart from checking the header. You can actually check URI as well. So for example, a particular URI is actually having a problem in the service, we can actually configure state error code against that particular URI as well. So let's just check first this particular header matching and see how many times we are going to get 503. Also, one more thing you can notice, if you are not actually sending this header, then nothing will actually be impacted and everything will actually go to the latest. Sorry, actually, yeah, fine, no worries. So it's basically what I'm doing is I'm trying to show 50% traffic still go here, and the 50% traffic is actually getting the 503. But yes, you can actually configure another version where you can make sure that only some traffic which is actually getting a 503 and other part of the traffic will actually go smooth. But in this case, yes, so the upcoming traffic will actually divide into 50%. Okay, so let's just quickly configure this particular virtual service changes. Yeah, okay. So now what will happen here is, first of all, let's, if we don't actually, let's just get the auth token first. Yeah, so if we don't send the header, of course nothing will happen, and all the traffic will actually go to the new service, which is upcoming service. Once we add the header, which is basically xlease header, and the value is canary. Now we should actually see an error called 503, which is fine, right? So this is what we want. So whenever we send this header, we always going to get 503, but again, this is only happening 50%, right? So some of the request will actually go through usual service, and some of the requests will actually get the 503. So this is how you can actually kind of release some pressure or some resources by capping your faulty service, so that the service will recover. If there are large processing going on which actually block other resources, in that case you can actually straight away very quickly put this fault, custom fault, which will stop extra traffic coming to the service, and service will get more time to execute and finish up all the pending queues. So in this is how you actually do fault injection. Uh, in the last section, I wanted to actually talk about gateways and how we actually make dark releases, especially when we're talking about the web UI, where you can see the changes directly on the consumer side of it, not as a APIs. So let's just talk about that in the next section. Thank you. Right. So in the last use case, we wanted to actually introduce concept called gateways, right? And it's basically, and I just wanted to go through why it is needed. So whatever the use cases we gone through so far, it's basically the APIs where we were sending requests between different services, right? So if you see how we accessing our query service is actually coming from the logistic gateway service, right? Which is again another service running a Istio proxy, sending this to the workload, which is again running a Istio proxy in the pods and then sending to the query. So everything is well connected, right? Both services, both workloads running in the pod will have Istio component injected, right? When we're talking about accessing our web UI, a retail app, which is basically, for example, this one, right? This is something which is actually coming through a load balancer, which is provided by AWS. Now, the load balancer sending requests directly to a retail app pod or service, basically, and then the pod. There is no kind of STO proxy or a sidecar which is basically running with the load balancer. So there is no way when the request landing on retail app pod to identify uh, you know who is actually sending it, in terms of who is actually generating from the service mesh perspective. So to actually overcome that kind of limitations, um, STO provides a gateway, which is basically a ingress load balancer. So it is basically a entry for any request coming outside of your cluster should actually first land onto the gateway, which is an ingress um, uh, component of STO. And then from there it will actually put all the metadata around that request, so that when it's actually reaching to our query service or our retail app service will then identify and apply all the configuration we have done so far with the virtual service, like for example weight around the number of requests, dividing between different versions, checking headers and all those kind of things. But to do that you have to have the gateway who can actually first get the request coming outside of your cluster and then translating that into Istio kind of request, right? So to do that, what we need, okay, before we actually jump into our gateway, I just wanted to show you that we have two versions of our not the order app, retail app, two versions of our retail. Again, the way we actually done for the query service, we have an upcoming version which will have some new functionality which we can see on the browser itself, and then we have the latest one which is currently running without the new functionality. So right now if you see, it's quite difficult to actually show that difference, so I have to actually use two different browsers because of the caching thing. But the difference here is, so for example, if I go and add cart, the different here is that we added the delivery instructions. This particular text box wasn't there in the latest version which is currently running. It's only coming in the upcoming version. And for the next, sorry, for the latest version which is currently running, if we just click on the add cart, it does is only talks about the delivery address. There is no delivery instructions basically, right? So these are the two, and it's both are running on the same URL you can see here. But basically this is just a Kubernetes, so doing, sending 50% of the traffic to the new one versus the, the latest one which is running. Right, so let's configure gateway here. So what we are doing in the gateway here, the virtual service is exactly the same, right? What we did in query service without the gateway is basically what we are saying here is that if you match this particular prefix in the URI, send all the traffic to the latest, right? Although we have configured latest and upcoming, but currently we are only going to try direct traffic to latest. And what we are saying in the gateway here is that anything which is actually lending from outside of our cluster should actually forward it to this particular service, which is basically based on this matching URL and based on this host, which is our retail app, right? So everything which is coming here on this particular gateway, Ingress Gateway, will actually direct to the retail app, right? So let's just apply this and test. So we can configure gateway. Right. So what we are saying, so basically, right now, if you see our URL, this is our load balancer URL, which is basically AWS load balancer URL. But now, because we now configured gateway, we need to use Istio Ingress Gateway URL. That is where whenever we sending a request through Ingress Gateway, everything now will be checked, matched, and then logically redirect to our various different services, whatever the configuration we made. But if we use this particular load balancer, then Ingress Istio will not actually come into the picture, because it will not be able to identify the other metadata which is associated with Istio, because load balancer doesn't really running any kind of Istio sidecar or any kind of pod or any kind of component. Right. So what we can do here is we can, yeah, we already configured this. Everything should actually go to the latest, which is basically the current version. So the new thing should not show. Now, before we access, we need to actually get um, Ingress Gateway URL. So if we just run this Istio system, sorry, yeah, so this is Istio Ingress Gateway, and this is the URL. So if we actually use this URL here, we should actually get our website. But of course there is no if we click here and sorry, just let's just sign first, and if we just go and click here, we should not be getting any new feature because it's we are not directing that. So the next thing what we will do here is to actually demonstrate how we're going to display the new feature or kind of a dark release. We again going to update our virtual service. We don't need to actually update the destination rule anymore. Virtual service, and what we're gonna do again, exactly the same thing what we did with query service. We're going to check for a user header. Basically what we are saying here is that when somebody logged in, we are actually adding his user ID into HTTP header before we sending request to the server, and based on the header we are identifying whether we should be showing the new feature to this particular user or not. So there is a kind of a marketing people decided to actually give this new feature to certain users, and based on the user header we can actually identify whether we should be showing or not. So it's a quite a simple kind of matching. Everything which is having this particular header and value should go to the new feature, upcoming feature. Otherwise everything is stayed in latest. Now what we can do here is we can actually, so let's first apply that thing and then we can test. Okay, so this the virtual service is reconfigured now. Now testing here is bit tricky, right? Because of course we need to set that header, and this is like a browser-based application. So what I've done is I've actually used this tool called mod header, where I have actually configured exactly the same header, right? So whenever this header is presented, we can see the new feature coming up. When we remove this feature and refresh the page, that feature should not be here, right? So let's just test here first, and you can see the new features, the new text box is coming. Now we can actually just update this value to something else, and hopefully when we actually hard refresh and go here, the new feature is not coming. So this is how easily we can actually release kind of a risky code, where we wanted to give, not only we wanted to get into market fast, but we also wanted to get some feedback from the end users, and that is where how we can actually protect, secure, and release new features using header based matching, using kind of different proportions of request going through one service by another service, using URIs and other logics as well. So this is how we can actually do the traffic management, and that will conclude this particular section of traffic management. Thank you very much.